All right, radian measure. So radian measurement is another way to measure angles, and it's different than degrees. It measures the same thing as degrees, but it's a different measurement unit than degrees. Radians are a way of measuring that's based on the radius of a circle. So over here, I have a little picture um, where it shows this is the distance of 1 radian, and 1 radian is the amount of angle swept out so that this arc length right here, this length of this arc up here, is the same distance as the radius. So this is the same as this distance, which is the same as this distance. And we can do a little bit of finagling here. Let's see. There we go. What would we have going on here? Use some blue. So that amount would be 2 radians. I'll just write 2 rad. And if this distance right here is r, and this distance right here would also be r, then this entire distance, that would be 2r. Let's see here, duplicate, come down here, remove that. Until there's 2 of them there, delete. Okay. All right. And then here, I'll do this in pink. This entire distance would be 3 radians. 3 rad. That's very messy. And this entire distance, that would be 3r. There'd be r here, r here, r here. 3r. So we can keep doing this, and you'll notice if we do that we don't end up all the way. We don't end up. Guess I could just rotate this guy, huh? From here. We end up with 1 radian, 1 radian, 2 radians, 3 radians, 4 radians, 5 radians, 6 radians, and then like a little bit of leftover area here. But the nice thing is we can relate the circumference of the circle to the amount of radians it should take to cover it, right? 3 radians covered a distance of 3r. And we know that the circumference of a circle is 2 times pi times r, the radius. So if there are 2 pi r distance around here, and we saw how this matched up, right? 3r was 3 radian, 2r was 2 radian, 1r was 1 radian. That would mean that if 2 pi r was the distance, that 2 pi is the amount of radians in an entire circle, and that is true. 2 pi radians. Equals 1 circle. So 360 degrees, there's a little degree symbol there, but it's down so far. We'll put it up here. 360 degrees is equal to 2 pi radians. This means that we are able to switch between degrees and radians. Because the two of them are the same, we call that a unit fraction. So 360 degrees is the same as 2 pi radian, and radians are unitless. They're unitless measures, so we typically don't write rad there. I think there's a note down here, yeah. They are unitless. We typically don't write rad. If you don't see any degree symbol, we assume that angles are written in radians. If there's a degree symbol, then the angle is in degrees. If there's not, then it's in radians. So 360 degrees is the same as 2 pi radian. Those are, because they're the same number, because they represent the same thing, as much the same as 12 inches is the same thing as 1 foot. So if you divided those together, you would get 1. Um, we can simplify this fraction a tiny bit, and we get 180 degrees over pi radians, writing that just for the beginning here. That is 1 conversion factor. This is the same thing as pi radians over 180 degrees because they are the same unit. They are measuring the same thing. So 180 degrees is pi radians. So if you want to switch from degrees into radians, maybe I'll shrink these guys a teeny tiny bit, move them up there. If you want to convert from degrees into radians, you multiply degrees by pi over 180 degrees. And you can think of this if you think about convert unit conversions. If you're multiplying, let's say, 90 degrees, do it this way. If you're multiplying, let's say, 90 degrees by something to convert it into something else, you want degrees down here on the bottom so that the degrees cancel out, so that the units cancel. Degrees, degrees, they cancel out. And this is pi radians. You end up with pi over 2, by the way. 90 degrees is the same thing as pi over 2 radians. And to go from radians into degrees, you multiply by 180 degrees over pi. So if we wanted to convert negative 405 degrees into radians, we would take negative 405 degrees. Again, we want the degrees to cancel out, so that means the 180 should be on the bottom, times pi. Honestly, let's see. Make that a little less thick there. All right. So then doing 405 divided by 180, that comes out to 2.25. I'm going to leave it as a fraction. So that comes out to 9/4 pi. And the way we typically write radians, we write it with the pi in the numerator of the fraction. So we would say 9 pi over 4. 9 pi over 4. And we don't need to write rad because it's a unitless measurement. So if nothing is written, we assume radians. Now let's convert this radian measure, 4 pi over 3, into degrees. To convert into degrees, you're multiplying by 180 degrees over pi. You'll notice that these pi's will cancel. That typically happens when you're doing conversions from radians. Not always, but typically. And then you just have 4/3 times 180, which is 240 degrees. So 4 pi over 3 in radians is the same measurement as 240 degrees. So some quick math here. 1 revolution, which is 360 degrees, that is 2 pi radians. A half revolution, so half of 360 is 180, half of 2 pi is pi. So 1/2 revolution is pi, and then half of a half, which is a fourth, you divide 180 by 2, you get 90. If you divide pi by 2, you just get pi over 2. So let me kind of label this guy here. We're going to cut this one into 8 pieces to begin with. Let's see, can I make this? That's good. This is 0 radians. It is also, because it's the same as 360 degrees, this is also the same as 2 pi radians. That would be going all the way around. And we said that 90 degrees, which is right here, was pi over 2. And we said that 180 degrees, which would normally be right there, we said that this was pi. But let's finish filling out the rest of it. Let's finish filling out the rest. So we're going to cut this guy into 8 pieces. So it's cut into 4 right now. Cutting into 8, this is the same as our 45-degree angles. So we're taking 2 pi and we're dividing it into 8 pieces. 2 pi divided by 8, that's going to be pi over 4. So each of these segments, each of these 45-degree segments, is a pi over 4 jump. So this very first spoke, this is pi over 4. Now, really, we're just counting up by pi over 4s. So pi over 2, this is really 2 pi over 4, because it's another pi over 4, but 2 pi over 4 simplifies to pi over 2. Another pi over 4 later would be 3 pi over 4. Add another pi over 4. This guy right here is actually 4 pi over 4, but we leave it as pi. This will be 5 pi over 4. This is 6 pi over 4. I'm going to leave a little arrow here. This is 6 pi over 4, but that simplifies down to 3 pi over 2. And then this is 7 pi over 4. And 2 pi is the same thing as 8 pi over 4, just simplified. So that's splitting it up into 8 pieces. Those are what those middle spokes are. Those are those 45-degree spokes. So you really want to be thinking pi over 4 equals 45 degrees. This is really important to understand, to really memorize that pi over 4 is a 45-degree angle. And any of these middle spokes are going to be over 4. We'll do this again and hit those outer spokes. Once again, we will say 2 pi is 360 degrees, pi is 180 degrees, pi over 2 is 90 degrees. We're going to cut into 12 pieces this time. So cutting in half, now we have 2 pieces. And then cut into thirds. So that one isn't a third. Technically, thirds would be here. So thirds on each side, rather. These are cut into thirds. These are cut into thirds. This is 6 pieces. We now want 12, so we use the middle spoke here. Not the real middle spoke, but the middle of each of these pi segments. There we go. This time, we're cutting 2 pi radians into 12 pieces. If we simplify, that's a pi over 6 jump each time. So this is 0. This is 0. This is pi over 6. This is 2 pi over 6. Oops, and I forgot this guy here. 3 pi over 6. 4 pi over 6. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. And 12 pi over 6. However, some of these simplify down. So 2 pi over 6, that's really just pi over 3. 4 pi over 6, that simplifies down to 2 pi over 3. 6 pi over 6, that's pi. 8 pi over 6 is really 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 is not 8, is 5 pi over 3. And 12 pi over 6 is 2 pi. Put another page in here. I'm going to duplicate this page real quick and erase all this. I'm just going to put this all together now. All together. So we have 0/2 pi. This one is pi over 4. This is pi over 2. This is 3 pi over 4. Pi. And really, let me make these guys. Make these guys black. Boom. This is 5 pi over 4. This is 3 pi over 2. And let's see, here we have 7 pi over 4. This is pi over 6. This is pi over 3. This is 2 pi over 3. This is 5 pi over 6. This is 7 pi over 6. This is, where am I? 4 pi over 3. 5 pi over 3. And 11 pi over 6. And I want you to recognize some stuff here. So first of all, the pi over 3s, look at those. Those are on the same axis. They're straight across from each other. Oops, let's go there. So anything with the same denominator is straight across from itself, right? Moreover, the numerators, I want you to pay attention. So for this first quadrant here, the numerator is 1. It's just pi, 1 pi. Num is 1 pi, so just pi. And that's in quadrant 1. In quadrant 2, notice that the numerator is 1 less than the denominator. So this is 2 pi versus 3. So 1 less than 3 is 2. 1 less than 4 is 3. 1 less than 6 is 5. This is just a great way of memorizing this unit circle and the radian measurements. So the numerator, 1 less than the denominator. And that's in this quadrant over here. 2. For quadrant 3, notice that it's all of them are 1 more. 1 more than the denominator. 6 add 1 is 7. 4 add 1 is 5. 3 add 1 is 4. So in quadrant 3, the num is 1 more. Num is 1 more than the denominator. And in quadrant 4, this is quadrant 3, in quadrant 4, each of the numerators is 1 less than twice the denominator. So 2 times 2 is 4. 4 minus 1 is 3. If you double 3, you get 6. That's what I'm getting at here. Double 3, you get 6. 1 less than that is 5. Double 4, you get 8. 1 less than that is 7. Double 6, you get 12. 1 less than that is 11. So this is num is 1 less than double the denom. In quadrant 4. All right, so that is radian measurement. Those are the special radian angles. In our next video, we'll talk about how to write radians in standard, how to draw radians in standard form. I'll see you in the next video.